Natalie. Okay, thank you. Well, I say that when the both equations are nonlinear, entonces it's impossible apply substitution, no? Entonces maybe elimination is good. For example, I remember the key idea for elimination is you multiply, for example, you multiply this equation. Remember, there are no unique way to, we have not only one strategy, we have no infinity, but we have some strategy. If you multiply this entire equation by -2, what is my goal? What is my goal? What is my intention? Well, when you multiply, it says minus 2x squared. Do you see? And now it's ready for elimination, that part. Okay, minus 4y squared equal -44. And this is my new equation too, by the way, it's identical. No twin brother, but it's a brother, right? It's the same family, it's the same equation, it's depending equation. Now you put together first and second new, this and this together. If you adding column by column, 1 plus 2. This is canceled. That was the intention. We have minus 3y squared equal 17 minus 44 gets -27. Divided by -3 both sides. Y squared is equal to +9. And you apply square root because it's quadratic equation, you know, using the square root method. Y alone is plus or minus 3. Okay, so you have two values of the y. That means that maybe we have two solutions, or I don't know. So you using this, for example, one by one. Oh no, one by one. Look, because I take advantage. The equation I select, for example, I select the equation 2. I don't know why I select the equation 2, and you copy x squared plus 2 times. Does it y you replace by +3 or -3 or both? Because when you square, become positive, right? Equal 22. So you can do separately positive and negative, but you get the same answer, right? This is 9, 18, x squared plus 18 equal 22. X squared is equal to 22 minus 18 is 4. And one more time you apply square root both sides, and you get x equal plus and minus 2. Okay, so now let me try to understand, because it's a little bit complicated, at least for me, no? A little bit. Apart after. Suppose que I plug in +3. We get two values. Okay, it's 2 and -2. And when you plug it in, the problem was KD simultaneously -3, you get the same answer. It's totally irrelevant, regardless the plus or minus. So actually, the interpretation is that we have 4 points. The points are 2, 3. The points are -2, 3. The points are 2, -3. And the points are -2, -3. Make sense? Okay. Now, as always, by confirmation that we are doing well, that we are the best, we put in decimals, right? Let me show you. There you go. This is example 4. Here. Do you see decimals? Yes or no? Yes. Cool. Look at the example 4. The example 4, I put equation. I put the 4 point we found. Look, this is the answer. Graphical representation. In this case, one equation gets the orange color is ellipse, but it's vertical ellipse. The major axis lie on the y-axis, And the purple color equation is another elixir, but the major axis lie on the x-axis. And the solution is this point you see in color. Cool? Clear? Okay. Let's move in now. See, everything is okay. Let's move on now to the easy topic, que is let's come back to the whiteboard. Switching whiteboard. Okay, there you go. To the inequalities and system of inequality in 2D. So inequality and system of inequality in 2D. Okay, 2D means XY plane. Okay. Okay, let me start for elementary example. Example 1. Suppose 3x minus 2y less than 6. Okay. The solution of this inequality you can represent graphically or analytically. I prefer graphically to see. So this is most important to visualize graphically this. Okay, for doing this job, I propose the following strategy always. You, for example, you immediately remove the inequality and convert to equation. I know it's not the same, of course, but this is the related equation que help me to understand the inequality. How? Well, let's do it by hand. After, of course, we are using decimals. Use of y is minus 2y equal minus 3x plus 6 divided by negative 2, divided by negative 2, divided by negative 2, y alone is equal 3/2 x minus 3, because 6 divided by negative 2 is negative 3. And we are doing, why not, the graphic of this line. Okay, suppose, let me try to, not decimal so far, let's do it by hand, like a, you know. Okay, let's see. Io direi suppose rectangular coordinate system. Suppose rectangular coordinate system. Okay, this is the last time I'm doing this, but I want to illustrate at the beginning. Okay, entonces you compare immediately with the equation that you know very well, que is y equal mx plus b. And remember, b is a y-intercept. In this case, minus 3. So I plot the point here. Okay, the point 0, minus 3. And this is a slope. And the slope I know very well is one number que is like a rise over run. Okay, in this case is 3 over 2, is run is 2 and rise is 3. And you move it upward, because when the positive is upward, when the negative is downward. 1, 2, 3. Rise is 3 and 2, 1, 2. We get the second point here, okay, the point 2,0. And do the line. Now, What kind of line? We have two possibilities, solid line and dotted line. What is the convention to understand this? Solid line is when my inequality contains equal sign. Look, my original inequality is a strict inequality, no equal sign. Because that means when it's solid, que incluye the line, like inside the solution. Es obvio que no, in this case. Entonces, dotted line. Dotted line is when you have less than or greater than. And so you have less than or equal or greater than or equal, you put solid line. In our example, no. And this line is our famous related line, split the plane into semi-plane, above the line and below the line. How do you know what region you shape? Well, there are many ways to do this. There are many ways to identification this. One way I like so much is you come back again to the beginning, but quickly, 3x minus 2y less than 6, and you isolate the y again, but not in the equation, in the inequality. Minus 2y less than minus 3x plus 6, and divided by -2. And repeat again the idea. So it's better, guys, doing like inequality, and after you change the sign, the inequality to equation. It's much better. And when you divide by negative number, it's obvious, you remember that you reverse the direction of the inequality sign. So 3/2 x minus 3. So it's the same thing that we computed before. But this is important because sometimes it reverses, sometimes no. Depending if you multiply or divide by negative numbers. If you multiply or divide by positive, no, it stays the same. Therefore, this symbol indicates what is greater than is logical, no? It's above the line. Okay, see, it's less than and below. That's a one possibility to identification. Below the line. So you highlight in the story. The solution is that part. Include the line? No. No include the line. This region. Any point here. A solution? Yes. A solution? Yes. A solution? Yes. A solution? Yes. On the line, a solution? No. Outside, a solution? No. Okay? It's a one way. Another way is, well, you take testing point. Totally arbitrary. Testing point. Testing point. And you testing because we have 50-50 possibility, you know? It's above or below. Testing point. The most popular testing point, 100% work, but in the 99% work is the origin, 0,0. This is x equals 0, y equals 0. And you here, supposedly when you plug it into the original equation, you get true statement. Let me try. 3 times 0, replace x for 0 and y for 0, minus 2 times 0 is less than 6. This is obvious 0 less than 6 is true statement. That means que 0,0, que is this point, belong to the solution. Okay. Pero never I am doing this way. No. Hello. I open Desmo. Let me try. I open Desmo. I try to find inequality. System of inequality. Yeah. No. Yeah. No. Inequality. Inequality into the base. And the number of this script. I have 5 examples. Easy. Okay, look at that. I open Desmos. I want to share the screen to see Desmos. Come. Now, I suppose you see Desmos, yes or no? Yes, yes, yes. Okay, you, in example 1, you type in the equation. Not necessarily isolate the y. You type exactly the thing is given in the problem. 3x minus 2y less than 6. And you graph this. Bam. Do you see that? Cool. Do you see? Okay, so now we practice that. Basically, not necessarily linear. We practice non-linear. And we practice systems. The system is 2 inequality, 3 inequality, 4 inequality, 5 inequality. Because inequality is crazy. So inequality not necessarily 2 equation 2. No. Inequality, you have maybe 4 inequality, 5 inequality. And you see the application, guys, after that. Okay. Okay, let's move on to the whiteboard and continue inequality. Okay. Whiteboard. No. Inequality. Let me erase everything. Okay. Suppose this example, that's easy. That's easy. Suppose x squared, this is example 2 of the inequality in 2 dimensions. X squared plus y squared less than or equal 4. Well, I convert to equation because I am a little bit familiar with the equation. I identify, wow, it's a circle. It's a circle with a center is located at the point 0, 0, and the radius is 2. Where come from that 2? Square root 4, no? Because I know very well that the equation of the circle in standard form is x minus h square plus y minus k square equal radius square. And the center is located at the point h comma k, and the radius is r, que is the square root of this guy. Now, in this case, well, I do the graphic. Suppose this quickly after we see in this move, I promise. And this is the center here. 1, 2, 1, 2, 1, 2, 1, 2. This is our circle. And the challenge is, our circle is solid or is dotted? What do you think? Solid? Solid. The reason it's solid is obvious because my problem includes equals. So the boundary is inside the solution. And what part I shape outside the circle or inside the circle? What do you think? We had 2 possibilities, no? Inside because there's less than. It's one point of view. Another point of view is, so you select testing point, get the origin, 0, 0, and plugging in the origin, you see 0 squared plus 0 squared will be less than or equal 4. 0 less than or equal 4 is true statement. Sometimes confusion for the students. Bueno, professor, 0 less than 4 is true. Pero 0 equal 4, because this symbol includes both less than or equal, no? This is false. But remember, the connection is OR. If the OR is the logical operator, yes, at least one statement is true, the combination is true. Así es and no, and is picky. And to be true, must be true both. Because must be true the first, and true the second. But or no, or is flexible. See, at least one is true, this is true. Okay, this was easy example to understand. So now I promise that you see in this move for a few seconds. No, because I want to do example 3, que es very similar. Suppose que I change a little bit. X squared plus y squared is greater than 4. What do you think about this? What is the solution graphically for the example 3? Dotted. Okay, good. At the same circle, yes, I agree. Dotted. Dotted and outside. Cool. Dotted and outside. Sergio. Dotted and outside. Super. It's all thing outside. Okay, guys. Entonces, bueno, okay. Entonces, bueno, the solution always is graphic. Yeah, always is graphical. However, if you want to make picky and you want to find solution, bueno, it's easy. You copy solution is all pairs such that satisfy this inequality, is x squared plus y squared less than or equal 4. Likewise, in this case, solution set is all the pair x comma y such that x squared plus y squared is greater than 4. In this case, close inside, inside, any point inside, and in this case, any point outside. Let's do it quickly, or let's see quickly in decimals. Do you see this one or not yet? Do you see? Yeah. Example 2. Look. Oh. Example 2 is a circle. Actually it's no circle, it's a dist. Because it's inside, total inside, including the boundary. And example 3 is outside, remember, right? Oh, but you see the boundary. Desmo is fantastic. Desmo is a smart guy. Desmo is very well known. When there's no equal, it's dotted line. Look, and this is outside. Cool. Cool. Okay. So I want to complicate now a little bit. Let's come back to whiteboard. Okay, whiteboard. Erase the whiteboard. Okay, now we have not only one inequality. No. We have system. System is 2, 3, 4, 5. Let me start for the easy example, no complicated. Okay, suppose this example is example number 4, no? I guess so. Is y less than or equal 1/2 x plus 2. Inequality number 1. And 3x minus y less than 3. Inequality number 2. Okay, I would like to explain first of all by hand. And after I explain the fantastic way to solve this both together in decimals. Because the efficiency way definitely we are using in the test. Okay, let me try. Let me try again. I bring our image. Okay, rectangular coordinate system. Cool. Enlarge a little bit this rectangular coordinate system. Okay, this is the job is a little bit, not too long, but it's long. You need to take the first equation, the first inequality, sorry, que es y less than or equal 1/2 x plus 2. Yo temporary to understand much better convert to equation. I do the graph of this line. This line is, you know, y-intercept is 2, 0,2 is this one. Okay, and slope is 1/2. So slope is 1/2. Therefore, rise is 1 positive. That means it's over 1 and wrong is 2. So from this point, I move 1 over and 2 to the right, and you get the second point. Okay, by the way, the second point is 2,3. And we connecting by the line is linear. What kind of line are you using? Solid or dotted? What kind? Solid, very well, because it's include equal sign. And we are doing your best using the rule, no? I have no rule here. The rule in this whiteboard doesn't work. Look here, but it doesn't work. And another whiteboard I have before perfectly work. Okay, this is a new version. This is the new version. The rule is no update. Okay, so now so you split the plane into semi-plane. So what part is you shape, below or above? Above the line or below the line? I take the marker to shape. Below. How do you know get below? One of the reasons get below is because it's like that. Just in case you want to make sure you taking a testing point 0, 0 and verification and the original inequality. Si es true statement, que es obvio que es true because 0, 0 belongs to the solution. Entonces, okay. We are doing the first problem. Now we are doing the second. The second is 3x minus y less than 2. Less than 3. Sorry. And of course, as always, you solve for y. Minus y less than minus 3x plus 3. Divided by -1. Y alone is reverse this sign because you are dividing by negative number. This is 3x minus 3. Okay, not bad. What should I do? Well, you convert to equation because I feel more comfortable with equation. Yeah, I know get b gets -3 is my y-intercept 1, 2, 3 here. I plot this point 0, -3 and the slope is 3 positive. Entonces over. Entonces 3 positive 1, 2, 3 and 1. So 3 alone is considered like a 3 over 1. No? Rise is 3, wrong is 1. Okay, entonces 3 up and 1 to the right. And we get the point, this point is 1,0, no? 1,0, 1,0. And you are doing a line. What kind of line we are doing? Help me. Dotted line and shade above. Cool. Dotted line. By coincidence, pass through this point. And you shade using another color, maybe green. Above, because it's greater than. Look, this is the glue. Greater than, this is above, everything above the line is the solution. Everything is above. Okay, now, what's the answer? This is the green part. This is the purple color. Default, guys, default. You need to understand. When you have a system of equation or system of inequality, the connection in between these inequalities so you need to find the point that satisfies the inequality pink color and the inequality green color. Es obvio que es the intersection. Let me use another color. Let me use, for example, I don't know, maybe gray color. It's obvious que es this part. So any point satisfy this condition, graphically a solution of the system. Clear? Cool. Eso, of course, incluye this line que es solid, pero no incluye this que es double. Suppose I pick one point. This point is solution that exists? No. This point is solution exists? No. This point is solution? No, of course, no. Solution of nothing. And it's a solution of both. This is the idea. Manually. No Desmos. I want to explain now in Desmos super fantastic way to get the same answer, nice, beautiful, and accuracy. Okay. Everyone follow me? Okay, let me try. Let me try to open Desmos. Oh yeah. Here, over there. Over there. Okay, look. Desmos now. Okay. The language of Desmos is a little bit interesting. Look, do you see Desmos? I want to explain it. Pay attention. I copy here directly, and when you select this, you get the final answer. However, I want to temporarily delete that part. So let me use in my keyboard. Control X to cut. And you see in black color the solution of the why no? I copy Control B to paste. Okay, but this color bracket I have no idea who look like. I delete that. Okay, entonces I put in the red color. Entonces I recommend you using the same color. So you click here, hold the mouse, so left mouse, and select the color that you want, que es black. And you see that the intersection, that the solution is the dark region, no? In which the black intensify the color. It's a one possibility. But this is complicated when you have several inequalities. And two is possible. However, no. I don't like this. I like this way. Look. Undo. Oh, look at that. I copy my first inequality. You separate by curly bracket, and this understand is an. As you have two inequality, three inequality, you copy in the same line, and you separate curly bracket, and this understand is an combination. And find the solution. Cool, eh? Very. Okay, one more example, and let's move on to the complicated. One more easy. This is I call basic. Inequality to the basic. Let's do one more basic, and let's do complicated. Okay. Wow. One more. Okay. Do you see one more? Okay, now example 5. Easy example 5. No big deal. Easy. Okay, suppose we have non-linear, because example 4 was linear. Entonces, linear is easy, professor. And what about non-linear? Okay. Suppose this example. Y less than or equal minus x squared plus 4. This is my first inequality. Non-linear, exponent 2. And my second is x minus y greater than or equal minus 2. It's a linear. Okay. And we have another case y greater than negative 5. Wow, 3 inequality. Well, 2 and 3 are linear, but the first no, it's non-linear. Okay, let me try to do my best. By hand and after decimals. Okay, by hand now. Okay, I have the rectangular coordinate system. Okay, guys, this is the last time I'm doing by hand. After the super complicated example we see now, we are doing different. We are doing in decimals. Okay, this is a parabola. The first inequality, I immediately convert to equation. Okay, this is a parabola. Parabola look like or like that or like that. How do you know the up and down? Because it's negative. So when the, okay, in general, the quadratic function ax squared plus bx plus c, the control in what direction open the parabola is given by a. When the a is negative, open down. When the a is positive, open up. Entonces es obvio que hago parábola open down. Now the y in a set, suppose que I, to see more clear, I replace y for f of x, que you know it's the same, no? Y and f of x, but this is a function notation. Entonces I using the mnemonic device. I remember when you study another function que, for example, when you evaluate 0, it's a y in a set. Entonces minus 0 squared plus 4 is 4. It's a 4. It's a point 0, 0,4. 0,4 is a y in a set. I plot that. I have 1 point. What is a point? Is a point 0,4. I'm going to find the X-Intercept. Remember, you take the function, you enforce it to be 0. This is the formula for the y-intercept. This is the formula for the x-intercept. Similar to we are doing the polynomial, remember? Okay, entonces es basically minus x squared plus 4 equal to 0. Oh, easy. Easy. Minus x squared is equal to minus 4 divided by negative 1. X squared equal positive 4. Square root both sides. X is equal plus or minus 2. Entonces we have two x-intercept at the point 2,0 and minus 2,0. I plot that 2,0 and minus 2,0. The parabola entonces now is like that. This parabola is less than. Si es less than is, so you have the parabola, something like that. Entonces cuando I shape inside the parabola or outside, what do you think? My question is, this is solid parabola or is dotted parabola? Is solid. Okay, this is the parabola. It's solid, yeah, it's solid. It's solid, I agree. It's solid. How do you know it's solid? Because my inequality contains equal. That means the boundary can separate two regions, two countries, including inside the solution. And of course, the y is less than. This is less than. Entonces es obvio que es this part. Right? Okay. This gray color is only the solution for this. Okay. The other is easy because it's linear. It's similar to the thing we were doing before. So the only non-linear was the parabola. Okay. Now linear is x minus y equal minus 2. Immediately I convert to equation, guys. Oh, no. No, much better. More efficiency is solve for y first. X minus y greater than or equal minus 2. Solve for y. Minus y greater than or equal minus x minus 2. Divided by -1. Y is less than or equals, reverse the sign, x plus 2. Now you convert to equation. Cool. And when you convert to equation, it's easy. The y-intercept is 2. And the slope is 1. 1, 1. So we have this line, okay, by the way, is also solid line. A solid line. I don't know exactly if it passes through this or not. And it's less than, if it's less than, it's obvious que es below. So far, we are doing the gray color, now the pink color. The pink color. Pink. Is this. Okay, now the last one is y greater. The last one is y greater than -5. Greater than, no, see, greater than -5. You convert to equation. It's a horizontal line passing through -5 here, over there, but it's a dotted line because our inequality do not contain equal sign. But it's greater than to say you highlight. Let me use another color, maybe green, no, to emphasize. Que es this part. This part is above, no? Above this. Include this, of course. But I don't care because I need to connect in gray color, pink color, and green color. Okay, in my opinion, is I'm using black color. Is this part. So the part inside the parabola, the part below the first line and above the second line. Is the answer where the color overlap? Yeah. The color overlap. Yeah. Good point. She said okay, the answer is when the color overlap. This is the important word, overlap. The color overlap. Because, what is the reason it's overlap? Because it's and here, and here. You need to satisfy the gray color inequality and the pink color inequality and the gray color inequality. Okay, pero no. Don't. This is the explanation because I would like you understand much better. Pero no. Too complicated. Much better when you face one problem of this or more complicated. You open decimals. And let's do it. Look, I copy. I forgot something. Well, okay, no problem. I fix it. Okay, look. Okay, I fix it. The last one. The last one is open the curly bracket. I put the last one because the last one is y greater than no equal -5. Entonces now you define only one color. Look. You define only one color, que es the purple color. Okay, this line is the line y equal -5, I guess so. So basically, let me decompose little by little. Okay, look, I delete Bueno, delete no. Yeah, delete. Delete that part. Control X. I have a parabola, and the parabola is inside the parabola, and this solid parabola because it's equal. I put this part separately. Okay, I Control C, Control X, that part, Control B. And Desmos don't understand this alone because this is a connection with the AND. Okay, there you go, cool. In blue color. And here is the green color. Entonces you see a little bit, it's a little bit complicated, no? When you copy in that way, it's a little bit complicated because you don't understand very well. Well, yeah, I understand, but no, it's not very efficiency. It's much better doing together. You see? Fantastic, eh? Okay, let's see. Let me see. 1, 2, and 3. Complicated problem. Actually complicated problem. Everyone follow me, guys? It's clear, it's easy, it's understandable. Oh no? Okay, yes. Serio. Okay. Okay, switching to the whiteboard. This is whiteboard. Okay, erase the whiteboard. Suppose this. I want to complicate using several. It's a system of inequality. Suppose 3x plus y, 3x plus y less than or equal 6, 2x minus y less than or equal -1, inequality 1, inequality 2, x greater than -2, inequality 3, and y less than 4, inequality 4. And this is my system of inequality. Okay, in this case we have 4 inequality. So this is crazy doing by hand. Actually, this is crazy. It's crazy. So now, and this is no we are doing the application problem different inequality, and so I need to understand what the solution in order to find what are the actual feasible solutions. So now let me try to open this more, but not this folder, another more complicated folder, is the system of inequality. So yeah, system of inequality. I suppose it's this. This is example 2, I guess on 3. Let me see. 1, 2, yes, it's 2, example 2. Okay, cool. Let me show you. Share screen. Okay. Look. It's another script, of course. I switch in the moment switching with the now. You copy each inequality one by one. Bang, 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 bang. The first, the second, and separate by curly bracket. And when we come from that point, Professor, one of these is the intersection. Okay, basically, look, oh, what the hell? Look at that. Okay, this is typical. Look, this is typical. This is 1, 2, 3, and 4. Let's do it step by step. Suppose again, I remove the upper. Control. Control X. Okay, this is the solution of the first inequality. Okay. Control B. Remove that part and delete, of course, the curly bracket. You see another, right? If you want to do confusing, well, you change the color, put it the same color, no, black, black, black. So the dark part is the solution. Okay, we continue. Another inequality. You copy separately. The way you prefer, guys. Now I remove this. Control X. I remove the curly bracket and enter. And again black. Okay, black. Okay, you see a triangle, no? Something like that, a triangle. Okay, now finally the last inequality. Okay, is this. Okay, remove the curly bracket. Put the same color, of course. No green, no. Black again, black. Oh, the color you prefer. But actually, it's no triangle. Is, you know, that part is flat. Actually, it's a polygon. 1, 2, 3, and 4. It's a quadrilateral. Let me remove everything to start in the other options. You put everything together, it's perfect. Oh, and you see the solution. Okay, the solution. Because in the application problems, we are working on this solution. So this is one piece of the solution. Entonces, si you complicate your life doing by hand, or you are doing step by step, to say the screen is completely full of color, and you need to see in what parts dark. No, not good to analyze this. Okay. Okay. Super. Let's do one more. Okay, I consider it interesting. Suppose the example 5 I like so much. The example 5 is, wow. Okay. I copy in the whiteboard. Example 5. Okay, I call 5 in the. Okay, in the. And let me erase this. Share. Whiteboard. Cool. Okay. This is the next example. Okay, I call number 5, but actually number 5 is not number 5, and number whatever is x minus 1 squared plus y plus 1 squared less than, no equal, no, inequality, hello, less than 25. And the second, only two, is x minus 1 squared plus y plus 1. Wow, is similar, greater than or equal 16. And this is the system. Inequality number 1 and inequality number 2. And you see, you're familiar with this, no? At least the equation, no? The equation, let me see, equation is x minus 1 squared plus y plus 1 squared, suppose equal to feel more comfortable, 25. And 16, why not? It's the same thing. But this is 16. This is circle, yes or no? Remember the formula for the circle is x minus h squared plus y minus k squared equal r squared. But we have two circles. By the way, the circle have the same center. The center is located at the point 1, negative 1. Okay, h is 1, k K is -1 because the formula have a minus. When you see plus, it's because K is -1, so double negative become positive. And the radio is, and that's equal to 5, and that's equal to 4. But this is less than, this is inside the circle, and this is greater than or equal, this is outside. Okay? Do you have some idea how it look like the figure? Or no? Two circle concentric, one big radio 5, another is smaller radio 4. And this is outside 4 and inside 5. Look like a ring, yes or no? Ajá, it's a ring. Okay, entonces let's discover the ring in Desmos. Okay, there you go. Do you see this one, right? Boom. There you go. A ring. A ring. Look at the ring. Okay, let's do it step by step. Suppose I remove one equation separately. Control X. Oh, it's a circle with a center. It's located at the point 1, -1. I suppose it's here approximately. My mouse, my cursor. Do you see my cursor? At the center is the point. Let me see. 1, -1. And red, let me change the color red to see more clear. Red. Why not label? -1, -1. Cool. Now I copy another. Is this? Remove this, the curly bracket. Remember, the curly brackets only indicate both case and in between the inequality. And it's possible to put or no. In this one, no. In this one, or is you copy like that separately. Because you copy separately. Entonces, in my brain, professor, I can say the shading outside circle. Okay. Look. Outside this. Outside this. Do you see this one, right? Remember the inequality number 2? Inside is less than. Yes, you are right. Look, this is inside. Look. And outside is outside. So it's greater than. And together, boom, it's a ring. Okay? Is it clear the idea or no? Oh. Okay. Let me see. Okay, I screw up everything. Well, no, I want to copy again this. It's a curly bracket. Because although have a limit, you know. Entonces now es same thing. Well, okay. I want to copy and paste. Copy. Control C. Go inside. Control V. Copy. And now it's greater than or equal. Greater than or equal. Much better. Type it here. 16. Boom. Mia Morales. Yes. Guys, this is fantastic for solving inequality. Okay. Entonces, what is the reason that you need to solve inequality, professor? I don't understand very well. Well, there are one branch of the algebra. It's called linear programming. I want to explain right now. Okay. I want to dedicate the rest of the time to explain the idea behind linear programming. Linear programming was relatively recent branch of the mathematics that was created in the world in the Second World War to distribute the resources, the soldier, the food, and the world, a very, very efficient way. So now, what's the idea? The idea is you need to optimize something. Do you see the whiteboard or no? Let me know, let me know. Let me know. Do you see whiteboard? Linear? Yes or no? Programming. Yes, okay, cool. Linear programming. Okay, let me explain detail linear programming. Don't worry, be happy. So linear programming is the optimization method. Optimization means a mathematical try to find the best. Find the best option. Optimization. Oh, maybe sometimes it's a maximum or sometimes it's a minimum, depending, no? See, for example, the thing we are computer is good. It's money, for example, no? Or is, benefit. That you need to maximize this quantity. However, if the thing we are working is bad, like cost, you need to pay money, or you need to get something, your food and your resources decreasing, you need to minimize the cost or minimize the resource to do one specific job. Now, the linear programming problem contains two pieces of information. The first is the objective function. Objective function is a function that normally when it's linear is degree 1, so power exponent 1. It's a function that you need to optimize, so you need to minimize or maximize. Minimize or maximize. Entonces now, how do you know? Bueno, see the problem talking about, you see on the classes over, the last problem is one problem about the manufacturing of coffee. In the homework online, you see this kind of problem. That is the reason I explain this in detail. Entonces, the manufacturing of coffee, bueno, produce two kinds of coffee. One sophisticated coffee, another ordinary coffee. Entonces now the challenge is if you sold this coffee, okay, the challenge is how many package of the good coffee or the ordinary coffee you need to sell in order to get the maximum profit. It's one possibility, no? Not necessarily like that. That's one idea. So now we have objective function, and you recognize in the word problem that the objective function is the function that you want to optimize. Maybe profit, maybe cost. And we have constraints. And the constraints, it is the functions. It's also function, let me call G. Okay, you want to X, Y, maybe because they are dependent the X, dependent the Y. Okay, determine, because the basic of the constraint is no one. It's a set of the inequality. That is the reason that we study the system of inequality. Entonces now, these constraints give me, for example, this region, similar to the region that we studied before. Okay, it's important moment now. Look, this is the feasible region. So this is the region, the area in which the problem have sensing. Outside, it's a stupid situation. No good. No good. It's the feasible region. So my solution is inside here. But what is the optimal? What is the best? where's the maximum, where's the minimum, according to the problem. So you take, this is the solution for the constraint, okay, the constraint is a system of inequality. Several inequality. Now you take the objective function. The objective function normally is a line, it's linear programming. It's a line. Suppose this. So you have, well, I don't know, you have a family of the line because this line moving, for example, in this direction, this direction, this direction. Wow, here, tosh. I suppose that in the corners, I suppose in the corner of the polygon is the point of the optimization. Maybe when it's minimum or when it's maximum. So what's the goal? What's the final answer? Well, you evaluate the objective function in each corner. This is easy, guy, no big deal. Maybe it look like weird, but no. You evaluate the objective function here, and see you, for example, here you get $1 million. Here you get $2 million. You get here $0.5 million, and you get here $0. It's obvious you take the best option, get 2, right? Entonces nada, es easy. It's easy. The problem is que any problem optimization contains 2 pieces. Objective function, que es el function que you want to optimize, and the constraint. And the constraint depending of the problem, no? The constraint is using, first of all, to solving the system of the inequality, and you get the feasible region. There's one area in the XY plane. After you determine the corner, ching, 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 ching. I don't know, depending si es polygon, si es cuadrilateral, si es pentagon. You have 5 corners or 4 corners. You evaluate the objective function in any corner, because in the corner I know is when it's maximum or minimum, because that's when the objective function touch the first time the feasible region, is when the problem has sense. Well, no, too much blah blah blah. Let's see one elementary example, and you understand very well. And let's solve it using decimal, of course. In the lab online, you open your decimals, you put the inequality. Okay, suppose example 1 of the linear programming. Okay, there you go. Suppose this. Suppose I need to, let me simplify, no word problem, blah, 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 blah. No. First of all, the mechanical idea. Suppose we have the constraints of the problem. Constraints. And the constraint is a linear system of inequality. Suppose x greater than or equal 0, y greater than or equal 0, x plus y less than or equal 60, and y is greater than or equal to x. Inequality 1, inequality 2, inequality 3, inequality 4. This is my constraints. Okay, cool. And what is my objective function I need to evaluate? Objective function. Well, objective function is linear, always in linear programming, of course. It's 250x plus 150 y equals z. And c is the quantity. Okay, I want to maximize. I want to find the maximum. The maximum value of c that subject to the constraints. So we start backward. We start with the solution for the inequality. I open decimals, you copy that. Let me explain something. This and this is very, very, very interesting, because in any real life problems, suppose we are talking about money. Well, money, no. Suppose we are talking about fruit, truck, some physical object que es impossible to be negative. Entonces, obviously, one restriction is first quadrant. So you locate the solution in the first quadrant. because in the second quadrant, third quadrant, or fourth quadrant have no sense to talking about negative car or negative truck. No sense. This is physical. And inside we continue to manipulate that part depending of the inequality 3 and the inequality 4. No? And you determine the feasible region, que normally in linear programming is a polygon. It's a polygon. And after you have the objective function. The objective function is a line, and this is XY plane. It's a line, and you approach it to the line, and you, but not necessarily doing geometrical like that. You evaluate in the corner, and you determine the optimum. Okay, let's do it. Let's move on to decimal. I want to show you 2 examples, and after we are doing the word problem. Okay. Okay. Let me try to find linear programming script. Linear programming. There you go. I open that. Example 1. Cool. Look. This example is exactly the same. The inequality that I am using and I write in the whiteboard. Okay, let me share the screen. Boom. Boom. Do you see that? Decimals? Okay, cool. So now remember we have 1, 2, 3, 4 inequality. Why not? I determine the intersection, this line. Okay, in this case, form a triangle. Okay, the triangle is, look, the triangle is 0, 0, one corner, another corner is 20, 40, and 0, 60. How do you get that number? It's easy, guys. You take the second inequality, this one, the third inequality, and the second, and you solve it like a linear system of equation. So you solve it like a line and determine the corner. Okay, now, this is the crucial moment in which you evaluate. Okay, this is the thing I create here, one slider to move the objective function. This is the objective function that is, I copy weird here, but it's okay. It's the same. Okay, and you copy here. You see when you're moving, the first point that you touch is this. Boom. And this point is 11,000. 11,000. I don't know if it's dollar or si it's, I don't know. I suppose it's good because I need to maximize this. So you continue moving, and the other corner that you touch is 900 something. 900. Yeah, it's 900. It's 900. Entonces, no, it's not maximum. Y en 0 es supposed que es 0. En 0 es supposed que es 0. Yeah, it's 0. Hello. This is no money. Entonces es obvio que the solution of the linear programming, the optimum is 11,000, and this happened at the point 20,40. Okay. Let me complete the idea. To complete the idea, I go to the whiteboard again. Y I determine en Desmos, I found our feasible region look like that. It's a triangle. And this corner, and this corner. Not exactly like that, but approximately. This is a point 0,60. This is a point 20,40. And this point is 0,0. Wow. And this is the feasible region. And now this is a crucial moment. You evaluate the objective function in this corner, because I know that the corner is when they occur the optimum value. and then I evaluate. You evaluate, for example, Z at 0, 0. Wow, this is nothing. This is 250 times 0 plus 150. Oh, sorry, 3 times. Boom. Now it's okay. Good. Okay, the thing I try to explain is I a little bit reproduce the sketch of Desmos. And if you have a triangle, we have three corners, que es 0,60, 20, 40, and 0, 0. I want to evaluate this objective function, and the only thing I should do, plug it in any corner. 150 times 0 is obviously 0. So the C value for this point is equal to 0. Okay, it's equal to 0 at this point. Now C evaluate at 2040. Okay, this point is 250 times 20 plus 150 times 40. Calculate, you know, it's 11,000. Okay, the C value in this case is 11,000. The last corner, I need to finish every corner. Okay, is 0,60 is 250 times 0 plus 150 times 60, que es 9,000. Okay, entonces es obvio. This is C equal 9,000. Es obvio que this is the guy is the maximum. And my problem wants to maximize. Entonces, what is the final answer? Well, the maximum is this C in the objective function is 11,000 at X equal 20 and Y equal 40. Cool. Cool. Okay, so let's see application. Then spend the rest of the time try to do the application. But the application I have in the whiteboard. However, I erased the whiteboard 3,000 times, so I lost this. But don't worry, I try to recover it. In document. Okay, here my files. Linear program. Okay, I send today in the email. I send the link. In the email, I say the link. I send one PowerPoint. This PowerPoint contains 1, 2, 3, 4, 5, 6, 7, and 8 problems of the linear programming. I want to do today number 8, que es the last one. Why? Because it's similar, very, very similar to the problem that you can find in the homework online. It's similar. Of course, remember the homework online is not equal for every student. See, I open the problem, it's different number, different situations. So the lab is super good doing because the word problem is different for any student. No, the objective is the same. It's the same kind of problem, but the number is different, the situation, the name change a little bit, you know. Thus I try to illustrate this word problem, how you solving using, I call coffee problem, no? Linear programming. Entonces the rest of the problem of the PowerPoint is extra credit. I give you 2 points that you turn into me. The student gets 1. I don't want complain. This is not good for you, not good. The advanced student, you need to get super great. And remember, this everything is cumulative. Every extra grade is cumulative. Now, in the last test, you get a stupid grade, but you get A because you have extra credit. Then, to get extra credit, you can solve in the other 7 problems 1, 2, 3, 4, 5, 6, and 7, and you get 2 points for each problem extra. And you turn to me the same day that you send me the test, the reading test on paper, right? Okay, clear? Do you like? So you have no time, I understand. See, okay, see you no have no time, okay, I understand. Okay, to set this problem, let me read, let me try to understand. The understanding is the most important. After you set out the equation, you set out the optimization problem. Remember, the optimization problem contains 2 parts. The the constraints, que is a system of equation, and the and the and the objective function, que is the function. Okay. So now this talking about Donna Coffee House have available inside the store 1,792 ounces of the A. A is one classification of the grade of coffee. No, we have 2 kinds of coffee, A and B. Okay, I suppose que A is better than B. I suppose. I don't know. And 1,600 ounces of B grade coffee. Okay, it's not too much, but it's something. Okay, now the table illustrates also how you form in the package economy blend and superior blend. Of course, superior, the cost is $3, that's cheaper, and economy is $2. Okay, suppose que superior is best quality. However, in the blend, to form the economic, you mix it together 4 ounces of the A grade and 10 ounces of the B grade. This is the combination for mixing together. This is important, guys, in order to. Okay, so now the superior is 8 ounces of the grade A and 2 ounces only of the grade B. However, when you sell the superior $3 and the economy at $2, no? And you need to find the number of the package in order to maximize the profit. Okay, in order to maximize the profit. Suppose, how you solve that? How you organize this problem? This is interesting. Look, you call X. You take the piece of paper and you call X represent the number of package you sold of the economic. So this is economic blend. Okay, by the way, economic blend, you take 4 ounces of the coffee A, and or plus, whatever you want to call it. This is no plus, it's an. It's an, mix it with an 10 of the coffee bean. No? I say this according to the table. Look at that. Economy is this column. And this column is 4 of the A and 10 of the B. Okay, I understand this. And the Y, I call Y. Guys, this X and Y represent the number of package. So suppose economy, and superior. In this case, X is 2 and Y 1, correct? The number of package que you solve. The superior blend, the combination is the coffee A, it's better, right? And only 2 of the coffee big is not good. Okay, okay. So you, according to this information, you set out the constraints system of equation. Es obvio que the number of package is greater than or equal to 0. And the number of packets is greater than or equal to 0. So I have no sense to talking about package negative. That is 0. So suppose que one solution is, no, professor, no. You don't solve economy, never. It's about bullshit. This is nothing. You sell only superior. So X is 0. And Y is 200. I don't know. Now, this next equation is 4x plus AY. Why? Because I combine the grade A, the coffee A, and X 4, this 4 times X, and this 8 times Y. Give me the amount of coffee A that we need to produce. And the problem is that we have some restriction. It's constraints. Entonces, less than or equal 1,792 ounces, according to this idea of the problem. Okay. Now, what about this equation represent coffee A? It's a grade A. And we have another equation for the coffee B. It's this. And coffee B is 10x plus 2y less than or equal 1,600. Wow, and this is my constraints. And what is the objective function that I need to maximize? One of the money. The money is Z. Is the name, the letter that we're using for the objective function is equal to the price. When you sell one pack economic, you get $2, no? So 2x plus 3y. Okay, and this together is the pieces that we need to for solving our linear programming problem. Constraints and objective function. So now, this is the crucial moment. I go to the Desmos. We are expert doing this. We are. You put the system of linear equation, and you determine the feasible region, and immediately you determine the corner and evaluate the corner and the point of the corner, the objective function, and the story. It's doing. It's easy for us. I call coffee problem. Okay, coffee problem. Okay, let me try. Share the screen. Desmos. Do you see Desmos? Not yet? Do you see? Cool. Look at that. I copy in the first line the sequence of the inequality. 4x plus AY less than or equal 1,782. Open the curly bracket. I copy the second inequality. I copy the third inequality. I copy the last inequality. Here I have this. Look. Feasible region. The corner is relatively easy because you convert the inequality to equation and you intersecting this line to this line. Then you get the point. And this is the point. The point are 0,225, 128, 160, and 163,0 and 0,0. It's obvious because if you don't sell anything, you have no money. So 0,0 is theoretical stupid corner, right? So the thing is evaluate in the other 3 corners. So let me try to understand. You have 3 possibilities. First possibility is don't sell any economic blend, 0, and sell 225 superior. Okay, let's compute the money for this situation. You sell 128, so that's the intermediate solution. 128 of the economic and 160 of the superior. Okay, and this give me the money. Or 160 of the sorry, I make a mistake here. 160 is economic, X is economic, and Y is superior. 225 superior, 225 superior, 128 economy, 160 superior, or 160 superior and 0. Okay, 0 economy, 160 and 0 superior. Okay. Now I can see the objective function. Whoa. And the objective function I can move using the slider. This is, you can do it this way, but no, you are doing manually. And the answer is here is, when you evaluate, is $736. Okay. I don't know if it's maximum, no? We continue. Move this to touch another corner. In this case is it's 775. 75. Let me see. 5, not 72, 75. It's graphically is no accuracy, however, see, I know. Boom. Okay, it's $675, no good. It's no maximum. Of course, see, you continue moving in another direction is 320. No, so the best option is obvious as this. And it's no coincidence that this is money, because the first you touch, boom, is the optimum. Well, when you maximize. In opposite direction, suppose que this is no maximize, minimize. And those are the best option is the minimum. However, let me complete the idea and the whiteboard. Okay, in the whiteboard. Okay. In the whiteboard, you have that situation. You have the famous feasible region. Okay, what's the solution for the system of inequality? Okay, of course, too complicated. Not complicated, but it's too long. And to save time, I am doing decimals. So I discovered que it's approximately something like that. Okay, and this corner is 0, 0. And this corner was 160,0. And this corner was 128,160. And don't confuse the 160. This is 160 is X value, and this is Y value. And this is 0,225. Cool. Okay, what should I do now? Well, do you evaluate the function, the objective function, in this corner one by one? Let's do it. C. Evaluate at 128,160. I did that. It's 2 times 128 plus 3 times 160. And the answer was 736. Here, C value is 736. Okay, it's good. But I don't know if it's the best or not. Evaluate 160,0 is 2 times 160 plus 3 times 0. So no superior. It's obvious that the answer is 320. And C evaluate in 0,225. So no sell, economy no, only sell at $3.225 package of superior. And the answer is 675. Here is C equal 775, and this is C equal 320. And obviously, I don't do that. However, C is 0 in this case. Obviously, the best option is this one. Okay, that's the best business is doing for sell how many package? 128 of economic and 160 of the superior. And when you sell this, your profit is $736. It's the best option we have. Okay. This is, you know, you could earn more money, of course, but you need to improve your resources, you know. So the resources is limited because suppose que es a small business, no? Entonces this is the coffee que we have available. So you want to increase your money, so you buy more coffee and you produce more package. Clear or confusing? Clear or confusing? Clear. Do you see my face now? Entonces remember, you relax. Everything gonna be okay for you. Next week, we start review. Okay? I don't know, see we finish the Monday and Wednesday. See we finish the review in the middle of the Wednesday, so we start chapter 3. Okay? And Monday I will send the review package, and Wednesday I will send the reading test. And you have Wednesday, Thursday, Friday, Saturday, and Sunday, and you turn into me Monday. Monday at midnight. So basically Tuesday. Hey, Professor, this is Alejandro. I can make quick announcement. Okay. Alejandro, go ahead. Alejandro want to talk something. Come on.
Hello?
Hello, Doug, go ahead. Yeah, I hear.
All right, guys. Hello. This is Alejandro, or Alex for short. I'm your assigned tutor. You guys heard of me from WhatsApp, the WhatsApp group. I'm here just to remind you guys to come in for tutoring. It is important that even though you learn from your professor, you have to practice and you have to make sure that you understand the material and get the homework done early. That way that you practice enough to get ready for the test. Okay. I'm familiar with the homework that you guys are working on because the professor gave me something to work with, so I know what you guys are working with. But I need to make sure that you guys come here because I haven't seen you guys in like the longest time, right? So I have to remind you this because you don't want to do the homework last, because if you do the homework last minute, you're not really learning the material. You're just finishing it, and then you are just you're not really learning as much from the experience. Oh, I'm in the Homestead campus. Okay. That's actually a good question, Professor. The students know how to get to the STEM lab from Blackboard, right?
When you say the student stay, repeat the question.
Like they know the students know how to get to the Blackboard STEM lab. Like they know the steps to get there from your.
Well, okay. They want, you are familiar how you go to the virtual room and the Blackboard to get the tutor, virtual tutor? Yes, yes. I suppose Alice.
No,
I explained the first day. I suppose.
Okay. Okay.
Alice, could you repeat again your schedule? You are available.
Okay, I'm gonna write it. I'm gonna write it down.
Okay. In the chat.
Yes, it's gonna be Monday, Tuesday and Wednesday from 12 p.m. to 9 p.m. All right. Now I do have different classes, but I'm opening up my schedule because even those classes have yet to show up, and I hope that you guys know that if you haven't done classes before, if you have ever done your homework or anything last minute, when you come for tutoring, the tutors are going to get overwhelmed with a whole bunch of students from every class. So it's good that you guys come early, because if you come late, then you might have to wait for me to finish tutoring from other classes, or the other tutors to, finish with their classes. So make sure you come early as possible so you could practice. And of course, you guys already know that I'm on WhatsApp. So you, wow. Oh, okay.
No, it's
What?
okay.
You...
I changed that.
All right. So that's my schedule. That's where I'm at. I'm in the Homestead campus. There. And you know how to get to the room. Oh, also, my manager wanted to make sure that we all know that if you guys know that that registration is coming up, try to register for the fall semester as early as possible. All right.
Take advantage. Yes. Early enrollment.
Yeah.
Okay. Thank you, Alex.
You're welcome. That's it.
Any question, guy? Take advantage that Alex is with us now here. No problem.
Professor, the participation for class, does it count if we go to Alex too?
Yes.
Okay, thank you. That was it.
Okay, guys. See you. Nice day. Have a nice day.